In this video, we're going to continue our discussion on graphing quadratic functions. In this video, we're specifically going to look at how to graph the function when it's written in vertex form, which is what we see here. And the reason it's called vertex form is because it makes it really easy to identify what the vertex is. And this relies on what we've discussed previously about transformations of functions. You can think of this as a transformation of y equals x squared. Inside the squaring with x has been replaced with x minus h. So that tells us that we've had a horizontal shift. And then the plus k on the outside tells us we've had a vertical shift. So our basic y equals x squared function has a vertex at the origin. And so if we've shifted h units horizontally and k units vertically, which is what we see from the equation, then the vertex is now going to be at hk. For example, if h is 2, we have x minus 2, which we know shifts the graph 2 units to the right. And then if k is 3, it'll be shifted 3 units up. And so now the vertex is at 2, 3. The value a out front is being multiplied by the part with the squaring, so that value a, we know from our transformation discussion, could cause a stretch or shrink vertically. It could also cause a vertical reflection if a is negative. This value a is actually the same value a as we see in the quadratics where it's written ax squared plus bx plus c. The letter a is used both places intentionally because it's the same value. And we discussed previously that if the value a in that other form is negative, it means the parabola opens down, and now we can see why, because if a is negative, we had a vertical reflection, which means the parabola is going to now open down. So here's our first example. We have x minus 3 squared minus 4. So if we think of this as a transformation of y equals x squared, we've shifted 3 units to the right and 4 units down. So since the vertex was at the origin for y equals x squared, now it's going to come 3 units right and 4 units down, and it's going to be at 3, negative 4. And as we discussed in the other video, the axis of symmetry is a vertical line that runs down through the vertex. So since it's a vertical line, the equation is always x equals a number, and it'll pass through the vertex, which means whatever the x value is at the vertex is the number we'll see on the right side of the equation. We don't see a value a out front here, but it's 1 because 1 times this equation would give us the same equation, and so that tells us that the parabola will still open up. So it's just good to know, because then if we get a point below the vertex, we'll know we did something wrong. Depending on what we're doing with this function, we might be interested in where the intercepts are. So if we plug 0 in for x, that'll give us the y-intercept. Negative 3 times negative 3 is positive 9. I think sometimes the challenge for students is they'll do all the arithmetic here like this, and then I think the challenge is knowing what point to plot. So you're always plugging in a value for either x or y and then finding the other coordinate. So here we plugged in 0 for x, and we got a y value of 5. So since y is 5 when x is 0, we have the point 0, 5. Similarly, we can substitute 0 for y to find the x-intercepts. And so to solve this for x, we can add 4. And then we can take the square root of both sides. Don't forget the plus or minus. We know we should have two x-intercepts because we can tell here's the vertex. It's going to cross on this side and on that side. So square root of 4 is 2. So we have x minus 3 equals plus or minus 2. Let's split that up into two different equations. And so if we add 3, we have x equals 5. And here we have x equals 1. Now again, think about what we did here. We substituted 0 for y. So that means we're finding points that have a y value of 0. And what we found is that there's two different x values that give a y value of 0. So when x is 5, y is 0, and when x is 1, y is 0. So we have the point 1, 0 and the point 5, 0. And then we can just draw in the parabola. Mine's not going to look super great drawing on this. We'll look at another example here. So here we have x plus 2, which means if we think of this as a transformation of y equals x squared, we've taken that and shifted it to the left 2, and then we've also shifted it up 5. So the vertex that was at the origin has now moved left 2 and up 5. So it's going to be at negative 2, 5. If it's x plus a number, it's a little bit trickier to compare it to the vertex form that we've been using, but you can still do that if you rewrite it with subtraction, because the formula has subtraction. So if we rewrite x plus 2 as x minus negative 2, because that's the same thing, x plus 2 is the same as x minus negative 2. Now we can compare it. We have x minus h and we have x minus negative 2. So that means h is negative 2, and that's why the x-coordinate of the vertex is negative 2. But I think it's easier to just think of it in terms of your transformation. So we went left 2, so that's why the x-coordinate is negative. Axis of symmetry is going to pass through the vertex. So that's going to be the line x equals negative 2. And our value of a here is negative. So we had a reflection down before the shift, which means the parabola is going to open down. So we just need to get a couple more points here. The y-intercept is usually pretty easy to find. All you have to do is substitute 0 for x. So for this one, if we substitute 0 for x, we get negative 3 for y. So we have the point 0, negative 3. We could find the x-intercepts here like we did in the last one. They're not nice integers in this one. Really all you need is a point on either side of the axis of symmetry so that you can graph each half of the parabola accurately. So you can take any x value to the left of negative 2 and just plug it in and get what the y value is. So you plug in negative 3 or negative 4 for x, for example. You can also just use the symmetry over the axis of symmetry. So we have a point that's 2 units to the right of the axis of symmetry already graphed. If we go 2 units to the left then, at that same y value, it's symmetric because these points are the same distance from the axis of symmetry. And then we can just draw in the graph from there.